Okay, so hello and welcome back. So in this video we want to start talking about permutation. So basically to understand the concept of permutation, so let's see what we have here. So permutation is basically to understand the concept of permutation again. So we had in the previous videos, two videos, we had basically two examples. And these two examples, in example number 1, we were counting the different possible arrangements of the letters, such as rows. Basically we had the letters R, O, S, E, and we were counting the different possible arrangements of these letters, such as, for example, R, for example, O, S, E, R, O, S, E, or for example, R, E, O, S, R, E, O, S, and so on and so forth, right? Let me, because I don't really understand, I don't really remember the example number 1 here. So the question was basically find the number of 4-letter words with or without meaning, which can be formed out of the letters of the word form where the repetition of the letters is not allowed. So what we did was that we said that, okay, so we have these 4-letter words, and so since I have 4 letters here, so then that means that to fill this placeholder, I have 4 ways of filling this placeholder, which is basically 1, 2, 3, and 4 letters. Then, since repetition is not allowed, what I can do is that I can then whatever letter I have used in this placeholder, I cannot use it anywhere here anymore. Or to be more specific, I cannot use that letter here anymore, which gives me basically another 3 letters to use here. With the same logic, I would have 2 more letters to use here and one more letter to use here. So by the principle of mathematical there was a principle over here that I keep. By the fundamental principle of counting the number of all such possible words using the letters R, O, S, and E, keeping in mind the fact that basically repetition is not allowed, then the number of such words would be 4 times 3 times 2 times 1, which is equal to 24 words. You would get 24 words. Now this was basically what we were doing in example number 1. So in example number 1 of the previous section, we are actually counting different possible arrangements of the letters, such as R, O, S, E, R, E, O, S, and so on and so forth. Now here in this list, each arrangement is different from the other. Of course, it is different from the other. There is no way that on this list of 24 words with or without meaning, you could find any 2 arrangements that look exactly the same. They are, of course, going to be different, meaning that these letters in each of those examples, these letters are being basically moved around, so you would not get the same thing. You would not get the same word at all, never. So the order of writing the letters is important. So in this example, you can say that the order of writing the letters is important. So what that means is that, for example, ROSE, the word ROSE would be treated differently from the word, for example, ROES, in spite of the fact that they both have the exact same letters, and the only difference between the two words is that basically in the last two letters you have basically S and E over here, and now the only thing that you've done to get to this one, you have switched these two and you've gotten to this one. But of course these are treated differently, and treated differently. This word over here would be treated differently from this word, and of course the two words would be treated as two different words on this list, meaning that for example, if you were talking about, for example, suppose that you were talking about wearing a pair of pants with a, let's just say that we were talking about wearing a pair of pants with a shirt with a pair of shoes, right? With a pair of shoes. And suppose that, for example, in this situation you had, for example, 3 pairs of pants. You had, for example, 4 shirts. And you had, for example, 2 pairs of shoes. And you had 2 pairs of shoes. And you could, and suppose that you wanted to, for example, mix and match. So the 3 pairs of pants, that would be, for example, P1, for example, P2, and P3. The 4 shirts, that would be S1, for example, S2, for example, S3, and S4. The 2 pairs of shoes would be, for example, call them, for example, I don't know, I denote these with F1, for example, footwear, for example, F1 and F2, right? Now, the possibility of, for example, suppose that I take, for example, in one of these, when I'm mixing and matching these things, I want to, on a particular day, I want to basically wear this pants P1 with, for example, with this shirt S2, for example, with this pair of shoes F2, right? So what that means is that now you're pairing this pair of pants with this shirt with these shoes, right? Now it doesn't really, in this situation, in this particular situation, it doesn't really matter whether you write this as P1, S2, F2, or you write it as P1, for example, F2, P1, F2, S2, or whether you write it as, for example, S2, F2, for example, P1. They would all be the same thing, as long as we are talking about the same items of clothing paired together, matched together in order to be worn on a on a particular day. It doesn't really matter which one you mention first, which one you mention second, and which one you mention third on the list. Doesn't really make any difference. You would still be wearing the same set of clothes, and they would still look the same, exactly the same, whether you mentioned whichever item first or second or third. Doesn't really make any difference. But then when it comes to this list, okay, but then when it comes to this list of, for example, all the different words basically constructed from the 4 letters of the word rose, meaning that when you're taking all of these 4 letters ROSE, and out of these 4 letters you want to build as many words as possible, basically moving these around, then of course then ROSE and ROES are treated differently. It's not the same situation that we have here. So here the order of writing the letters is important. Whereas in this, for example, situation of wearing a pair of pants with a shirt, with a for example a pair of shoes, the order really does not matter. So each arrangement, now in this basically in this example where the order of writing the letters is important, and if you wrote the same letters differently, then the outcomes or the words basically would be treated as different words. Then each such arrangement is called a permutation of 4 different letters taken all at a time, right? So this is a fancy, of course, this is a fancy name for this, but you need to understand the situation, and then based on the situation, then link it to, for example, this name, which is, for example, the permutation of 4 different letters taken all at a time. Of 4 different letters taken all at a time. So this situation is called where basically the order is important. This situation would be called the permutation of 4 different letters taken all at a time. Now, if you, for example, if you were to use the same 4 letters R, O, S, and E, and if you were to, out of these 4 letters, if you were supposed to make, for example, 3-letter words using these 4 letters in the exact same way that you did it before, and so if you did it in the exact same way, in the exact same way, and the order of the writing of the letters was again important, this situation would be called the permutation of 4 different letters taken 3 at a time. Now here I'm calling this the permutation of 4 different letters because you have 4 letters, right? And I'm saying 4 different letters because the letters are different. Meaning that, for example, if I had RO, for example, RO, S and S. Then of course I wouldn't call this, for example, the permutation of four different letters. Then I would call it, for example, the permutation of 4 letters in which, for example, two letters repeat themselves. And then I would call it taken 3. I'm calling it taken 3 at a time, because you are taking 3 of them at a time to build basically 3-letter words, right? And so basically you need to understand the situation here, and then based on the situation, I'm giving this situation a simple name, like permutation. And then of course, to be more specific, I can say that the permutation of, well, 4 different letters, and the letters are of course different, so I call it 4 different letters, and taken all at a time, meaning that taken all the 4 at a time. Over here I can say, for example, taken 3 at a time. But you need to basically pay attention to the situation, and then based on the situation, just for now, learn this label or this name, and then we will make use of it in different parts of this in different parts of our work here in this chapter. Okay, so now basically, so as a definition, what we can say is that the permutation is an arrangement in a definite order of a number of objects taken some or all at a time. Or again, a permutation is an arrangement in a definite order of a number of objects taken some or all at a time. So let me write down the definition and we'll talk about what that means. So let's call it definition. Let's call it definition 1. So a permutation is an arrangement in a definite order of a number of objects taken some or all at a time. So what that means is that basically so coming back to the example of the number of letters of the words of basically now coming back to, for example, the letters ROSE, or the letters of the word rose, and we use these 4 letters in order to create all the different possible arrangements of the letters, meaning making basically 4-letter words out of these 4 letters. And we basically what we found was that basically ROSE, using basically if you are to create 4-letter words using these letters, what you need to do is basically you have basically these 4 letters over here. So you take basically first in the first placeholder, you have 4 different ways of filling this placeholder. The second placeholder, you can fill it in 3 different ways. The third one, you can fill in 2 different ways. And the last one, you can fill in basically 1 different way, or 1 way basically. So that was 4 times 3 times 2 times 1, which is equal to 24 different arrangements. And each arrangement, and of course in this basically in this example, we said that, for example, you write you basically, since there are 4 different ways of filling this placeholder, you would either choose R or O or S or E, and then after that you can choose, for example, O or S or E, or after this you can choose either S or E. After this you could choose either, for example, R, S, O or E. Or after this, for example, you can choose either S or O. Excuse me. Either S or O. And of course, when it comes to basically, now you can see that this is the second placeholder, this is the first one, and the third placeholder then can be filled in, for example, 2 different, or 1, 2, 1, basically 2. This is the second one. This is the second one. This is the third one, and the fourth one can be filled in basically only 1 different way, meaning that you have chosen R, O, S. So the only thing that you can choose here is E. Over here, R, E, R, O, E. And the only thing that you can choose is, for example, S. Over here, you can choose an R, S, O. Then the only thing that you can choose is E, for example. Over here, you can choose, for example, you have chosen R, S, E. And the only thing that you can choose is O. Over here you have chosen R, E, S, and the only thing that you can choose is O, for example. And over here you have chosen R, E, O, R, E, O, and then the only thing that you can choose is S. So you can see that. For example, over here, what you would get is R, O, S, E. Over here, you would get R, O, S, E, R, O, E, S, R, O, E, S. Over here you would get R, S, O, E. Over here you would get R, S, E, O. Over here you would get R, E, S, O. And over here you would get R, E, O, S. And of course then in the second run, for example, when O comes first, then O comes first in the words, and then basically you keep switching these 3 until you get all the different possibilities related to that choice, and then all the different possibilities related to that choice, and all the different possibilities related to that choice. And so you have 1, 2, 3, 4, 5, and 6. 6 times 4 is equal to 24, right? So then you would have 24 different words with or without meaning. created from these 4 letters. And so each of these arrangements, each of such arrangements is called a permutation, is called a permutation of basically a permutation of 4 different letters, here, of 4 different letters taken all at a time. Right? So now based on this, you can simply understand the meaning of the definition of permutation. Meaning that we said that a permutation is an arrangement, such arrangement, for example, some arrangement like this. So you can call this one permutation. This is another permutation of the same thing. This is another permutation of the same thing, and so on and so forth. So you can call this, so you can say that a permutation is an arrangement in a definite order. Meaning the order is important. Meaning that, for example, when you have these 4 letters, R-O-S-E is different from R-O-E-S, is different from R-S-O-E, is different from R-S-E-O, and so on and so forth. The order of these letters is of course important, so we say in a definite order. Of a number of objects, and the number of, when we say number of objects over here, we have 4 objects here, R, O, S, and E. The 4 objects could be 4 people. The 4 objects could be for example, 4 days of the week. The 4 objects could be for example, tables, for anything. 4, basically, it has to be 4 different of a number of objects taken some or all at a time. And what that means is that taken some or all at a time, you can basically, in the exact same situation, you can find all the permutations of the 4 letters R-O-S-E, for example, and take these letters and use these letters to make, for example, 3-letter words. You can take the same 4 letters, and using the same 4 letters, you can make 2-letter words. You can make, for example, you can make 4-letter words, and you can do whatever you want to do with that. But at the end of the day, you're taking the same number of objects, and out of the same number of objects, you're creating either, for example, you're taking all of them at a time, or basically some of them at a time. And I suppose there is a question that has arisen in my mind, and that is basically if you can make 5-letter words using 4 letters, of course without repetition, you cannot do that. Okay. So that is that. So that's the definition of that is the definition of permutation. Now, in the following basically subsection, we shall obtain the formula needed to answer these questions immediately. So I'm going to end this video here, and in the next video we will talk about the formulas related to permutation. I'll see you in the next video.